Alright guys, today we'll be talking about sets and subsets. To begin, I'd like to just create a quick illustration. Maybe this will get you a good idea of what they are. But I'm going to have a set of Marfa ISD students. I'm going to create another set of the Marfa ISD athletes. So of course, all the students aren't athletes, but this represents Marfa ISD athletes. But since Marfa ISD, the set of athletes, all of them belong to Marfa ISD students, the athletes is a subset of the Marfa ISD students. Now another thing we can do is the athletes, we can call it basketball and football players. So we've got a set of football players. Of course, we know that some of the football players are also basketball players. So we're going to kind of make them combine together. Okay. And since all football players are athletes and all basketball players are athletes, both of those are subsets of athletes, hence why they are smaller circles within the bigger circle. And once again, all athletes, the set of athletes, are Marfa ISD students. Therefore, athletes is a subset of the Marfa ISD students. Hope that maybe can clear things up when we start going over this with the number systems. All right, guys. So let's go look at some definitions real quick. So sets and subsets of real numbers. A set is a well-defined collection of numbers in this case. A subset is a part of a larger group of related things. There, for example, there is a set of students in the classroom. The class is broken up to a set of boys and a set of girls. The students, boys, and girls are all considered sets. However, the set of girls is a subset to the students in the classroom, and the set of boys is a subset to the students in the classroom as well, because both sets belong to the classroom. Counting or natural numbers is a set of positive numbers that begins at 1 and increases by increments of 1 each time. The set of counting natural numbers is noted by the symbol n. Example is 1, 2, 3, and forever on from there. Those are our counting numbers, just like you're counting on your hand. 1, 2, 3. Whole numbers are the set of counting natural numbers and 0. So the set of whole numbers is denoted by the symbol W. Example, now we start with 0, 0, 1, 2, 3, and on forever. Therefore, it is all the counting numbers plus the number 0. Next, we have the integers. The integers is a set of counting natural numbers, their opposites, and 0. The set of integers is denoted by the symbol Z. Example, going on forever all the way up to -3, then -2, -1, 0, 1, 2, 3, and then on forever. So it has the same numbers as the counting numbers, the whole numbers, but then all the negatives as well. Rational numbers. They're the set of numbers that can be represented as a fraction, a over b, where a and b are integers, and b is not equal to 0. Of course, b cannot be equal to 0 because we cannot divide by 0. The set of rational numbers is denoted by the symbol q. Example of numbers that can be found in the set of rational numbers are like -4, 0, square root of 9, because the square root of 9 is 3, 7.5, 8.3%, 2/3, and 8/7. So once again, the rational numbers consist of all the integers, the whole numbers, the counting numbers, natural numbers, and all the fractional numbers that we can think of. But of course, the number 2, for example, it can still be written as a fraction, it can be written as 2 over 1 or 4 over 2. So those numbers are still fractions, but I'm talking more about like these 2 over 3s, 8 over 7s, or our decimals, since we haven't counted for those numbers yet. So those will encompass all the rational numbers. Our irrational numbers are the set of numbers that cannot be written as a fraction, a over b, where a and b are integers and b is not equal to 0. Another definition they give on this one is they are non-terminating, non-repeating numbers. Just means they go on forever and ever and ever, and they never have a pattern to them. Examples of this are like pi. Pi is like 3.14 on forever. This number will never ever stop. And then, of course, another good examples are square roots that are not perfect squares. For example, square root of 5, square root of 6, square root of 7, square root of 8, square root of 10. Notice how I skipped square root of 9 because the square root of 9 is a perfect square and is the number 3. And the number 3 is a natural number, a whole number, and etc. But anything that's a square root of not a perfect square is considered an irrational number. All right, the real numbers are the set of rational and irrational numbers. The set of real numbers is denoted by the symbol R. So to get track of all our rational and irrational numbers, we call them the real number system. All right, here's some sample Venn diagrams. Just like we were talking about with the Marfa ISD students example. Right here we got our real number system. So we've got either the rational numbers or the irrational numbers. Okay, both sets belong to the real numbers, so they are subsets of the real numbers. But there are no irrational numbers that are rational numbers, hence why the two circles are apart from each other. Well, within the rational number system, you have the integers, the set of integers, which are a subset of the rational numbers. Within the real rational numbers and within the integers is the whole numbers, hence why they got a circle inside the integers, because it is a subset of the integers and the real numbers. And lastly, of course, the natural numbers. The natural numbers are a set of their own, but they are a subset of the whole numbers, the integers, and the rational numbers. There are, of course, other ways we can draw this out. Here's another example. They use squares in this one, where they got the real number system up here. Rational numbers and irrational numbers is two different sets within the real numbers. And of course, once again, kind of the same example with squares. You got the counting numbers as the smallest square, as they are a subset to the whole numbers, and the whole numbers are a subset to the integers, and the integers are a subset to the rational numbers. All right, so we kind of talked about that up in the top, but I just want to go over some example. We're looking at the counting numbers. So like the number 2 belongs to the sets of counting, natural numbers, whole numbers, integers, rational numbers, and real numbers. Because the number 2 belongs to the counting numbers, he belongs to all the other sets as well. Because the counting numbers are a subset to all the other sets. Another number, for example, the number 0. 0 is not a counting number, but it belongs to the sets of whole numbers. Therefore, since he belongs to the whole numbers, and the whole numbers are a subset of all the others, 0 is a whole number, integer, rational number, and a real number. Another example is like the number -5. He belongs to the set of integers, therefore he also belongs to the rational numbers and the real numbers. Another example, the number 4/5, our little fractional numbers or numbers written as fractions or decimals, belongs to the sets of rational numbers and no other set. But since he's a rational number, which is a subset of the real numbers, he does also belong to the real numbers. Another number, for example, is the number pi, which just belongs to sets of irrational numbers. And once again, since he is an irrational number, he is a real number. And real numbers, of course, include everybody. The counting numbers, the whole numbers, integers, rational numbers, and irrational numbers. Okay, let's look at some sample problems here. Well, the very first one. All right, so we got our real numbers here in this diagram, and under those real numbers we got the rational numbers and the irrational numbers, and of course within that we got the integers and the whole numbers. Is what this diagram is showing. The diagram above shows how some of the subsets of the set of real numbers are related. The letters represent numbers of the sets. Judy wants to replace the letters with actual numbers. Which letter could be placed within the number 2/3? Okay, well, 2/3 we've talked about is a rational number. So therefore, he would belong to this side. And 2/3 is not an integer or whole number, so he can only be a rational number. So it's either the letter U or the letter W. With our multiple choice, we see the letter W here for B. So B is our answer. All right, which diagram is not a correct representation of the relationship between the sets and subsets of rational numbers? Okay, which one is not correct? So let's look here at the first one. They got the bigger triangle is the rational numbers. Within that bigger triangle is another triangle, the integers. And within that triangle is the whole numbers. That is a correct representation of the sets and subsets. And the number 2.5 is a rational number. The number 7 and -3 are integers. And 0 is a whole number. So, I'm looking at this one, and I got confused later because I saw one of the answer choice that the book gave me. They said was D. Let me, 1 second, guys. I'm just looking this over. Well, I would have to say that A is not correct because the number 7 is also a whole number. So the number 7 should go within the triangle whole numbers. So this letter A is not correct. If you see what I'm talking about, that 7 right there should be with the whole numbers because he is also a whole number. So this is not correct. But, so this would have been a bad question to ask on the assignment. Okay, so let me show you why. Next, B, it says irrational numbers, and this is the way they're describing it. Rational numbers are negative integers and whole numbers, which is correct. Examples they give are like -3 and 0. And of course, the whole numbers is a subset to the counting natural numbers, which is 7. So this does follow along and is correct. Let's look at C. See, we got the counting natural numbers as a smaller circle, and the number 7, which is a natural number. Now we got a bigger circle with the whole numbers, which of course does encompass the counting numbers. So that's correct, and 0 is a whole number. Next, we got a bigger circle encompassing the whole numbers and counting numbers, which is correct. And we got the number -3, and -3 is an integer. And lastly, the biggest circle, of course, the rational numbers. And the rational numbers has 2.5, and 2.5 is only a rational number. So that is correct as well. Looking at D, they represent the rational numbers with a big square. And it shows 2.5, which is only a rational number, so that's correct. We got the subset integers in the rational numbers, and it shows -3, which is correct. The integers are a subset of the rational numbers. And the whole numbers are a subset of the rational numbers. The problem I have with this one is all the whole numbers are a subset of the integers. So this whole number circle should not be on its own or have some numbers outside. All of his numbers would be inside the integers. So the whole number circle should be inside the integers. So this guy is wrong as well. And that is the answer they gave in the answer key. But like I said, this A would be wrong too because that number 7 should be within the whole numbers as well. All right, which Venn diagram correctly describes the relationship between the set of integers Z and the set of whole numbers W? Well, we should know that the set of integers contains all the whole numbers, so the whole numbers are a subset of the integers. So our W, smaller circle, is inside our bigger circle, the integers. That does make sense because all whole numbers are a subset of the integers. So A is correct. Just to go through and look, B is not correct because we know that all whole numbers are integers, and this shows them as two different sets. C is wrong because it's saying the integers are a subset of the whole numbers, which is not true. And lastly, D is showing the two sets have numbers that are the same, but they have some that are different as well. But any whole number is also an integer, so this is incorrect as well. Alrighty. Well, let me get this one real quick. Just looking at this and showing y'all what this is. This number right here just so you can see. So negative the square root of 144 is equal to, well, square root of 144 is 12, and of course we got that negative on the outside. It's just like saying times negative 1, so we got negative 12. So negative 12, if you know, is the negative numbers, and it's not a decimal nor written as it's just not a decimal, and it is a nice neat integer. So he is an integer, but since he is an integer, he also has to be a rational number and of course real number. Okay, so going back over here, remember we got negative 12. We saw that it was an integer, rational, and real. So it can't be A because integer, irrational. It's not irrational. It is an integer, rational, and real. B looks right. It is not a whole number, so C can't be right, nor can it be D as well. All right, a list of numbers is shown. Which diagram shows the correct placement of these numbers? Well, let's look at these guys real quick. Let's break them down. Let me get it somewhere I can see it. 1 second, guys. Sorry about this. Just want to make sure I can grab these numbers. Okay. Taking them over here. So I'm going to make myself a list here. We've got our counting numbers, aka our natural numbers. I'm going to make a list. Then, of course, we've got our whole numbers. Then we've got our rational. Oh, I'm sorry, integers will be next. And then we've got our rational. And okay. So our counting numbers. Well, 23 would be a counting number, so let's write him down in the counting numbers because if he belongs to the counting numbers, he belongs to all the other sets. Okay, any other number. Look at negative 45. Well, negative 45 is just an integer. He is not a counting number nor a whole number. The number 0 is a whole number. And of course, he belongs to all the other sets after that. Negative 12 is just an integer. All right, well, negative 11 over 4, if you divide it out, it becomes a decimal. So he would belong in the rational numbers because he is not an integer, nor a whole number, nor counting, of course. 8.25%, well, that's like saying 0.0825. So once again, he belongs over in the rational numbers. And our last, one more. We got 1 4/5. That's like saying 1.8. Once again, decimal. So 1 4/5. And lastly, we got 79, and 79 is a counting number. Okay. So taking that, let us go back over here. Okay. So, which diagram shows the correct placement of these numbers? Well, here in A, we show whole numbers, and it shows whole numbers as 0, 79, 23. My only issue with this is 0, 79, and 23 should also be with the rational numbers, because they are whole numbers, but then again, they are integers and rational. And with this bubble, it's showing that these whole numbers, 0, 79, and 23, are not rational. That would not be correct, because all whole numbers are rational. All right, B is showing that we have our rational numbers on the top as -4/5, -1/4, -12, which is correct. That is a rational number. 8.25% is a rational number. -45 is a rational number. -11/4 is. That's correct. And then right under that set is the whole numbers is 0, and it is showing that whole numbers are a subset of the rational numbers, which is correct. And lastly, we got the counting numbers, and it's showing that the counting numbers are a subset of the whole numbers, and 23 and 79. So B would be the correct answer. And the explanation, because all counting natural numbers are whole numbers, and all whole numbers are rational numbers. That is correct. See what's wrong with C. C, kind of the same thing. They have rational numbers and whole numbers, and they're showing that some of the numbers are the same, but 0, 23, and 79, for example, are whole numbers but not rational numbers. That is incorrect. And D's problem is it's just going backwards. It's saying that rational numbers are a subset of the whole numbers, and whole numbers are a subset of the counting numbers, and that is not true. Alrighty. The diagram below represents the relationship between the sets and subsets of rational numbers. Okay, so looking here, we got rational numbers, then we got section B, then we got 0, 1, 2, 3. So this must be my whole numbers on the bottom. So if that's my whole numbers, a subset, the whole numbers is a subset to the next one, section B, would be the integers. So section B must be the integers. So we got to find an answer choice that has just integers in it. All right, A, -7/8. Well, that's wrong, because -7/8 is a rational number, but it's not an integer. So A is out. B, once again, 7/8. 7 divided by 8 will give me some decimal. Once again, integers cannot be decimals, so B is out. C, -7, 8, and -4. All these numbers are integers, so C is the correct answer. All right, the Venn diagram represents the relationship between the sets and subsets of rational numbers. They want me to label or analyze the relationships with the Venn diagram to identify the appropriate number sets using each of the following labels. So, let me see if I can grab all this, take it to somewhere I can write. I don't get the whole thing, but let's try that again. Okay. Alrighty. I think it'd be best if I just did a screen right now. I'll make it smaller, but be better in the long run. I'm just giving it some time. There we go. Alrighty. Let me get rid of that. No, it's a little small, guys, but shouldn't be too difficult, as this first set right here, 104, is a natural number. So I'm just going to put natural, aka natural counting numbers. So the natural numbers are a subset to, of course, the next set in line is the whole numbers. So whole, and 0 is a whole number. And of course, the whole numbers are a subset to the integers. And of course, -4 is an integer. No, my pen's not working. Now, lastly, guys, I'm sorry about the pen, but the integers are a subset, of course, to our last set, which is the rational numbers. All right, and that's what they mean by analyze. So we're good on that one. Okay. So once again, the 104 was a natural counting number. Number 0, the next set in line, would be the whole numbers. Next set after that, of course, would be the integers, -4, and then after that, our rational numbers, which do consist of 1/2 and 6.5. Alrighty, guys. Well, I hope you enjoyed the lesson. Hope there are no questions. And please get to work on your assignment when you get a chance. Thank you, guys. Have a good day.